Okay, so if you would have completed number 3 and number 4, your greatest common factor for number 3 is going to be 7m squared. And once you factor out your 7m squared, you should have been left with a trinomial 2m to the 4th minus 5m minus 1. On number 4, your greatest common factor should have been only the variables a, b, because there's not a greatest common factor between 3, negative 5, and positive 8. So therefore your answer would have been AB times 3B minus 5A plus 8. As I said before, when you are beginning to factor, you always look for a greatest common factor. The largest number that will go into your question, or your trinomial or binomial, whatever polynomial term you're dealing with. So let's look. We have x squared plus 14x plus 45. Now this is in standard form. So far, we have looked at standard form, we've looked at vertex form, and we've looked at factored form, which is what we're learning right now. Factored form gives you some very important information about the graph of your parabola. Just like vertex form made it very easy for us to see what the axis of symmetry was and determine the vertex. Standard form also gives you some information about the parabola. Factored form does as well. And so as soon as we finish learning how to factor, or refreshing our brains how to factor, then I will be glad to show you the uses of all 3 different forms and how they're valuable to you and what they show about the graph that we could actually use as simply a visual without having to do anything else. But getting back to factoring, so we have this equation in standard form, and so what we need to do is, just like when we were looking for our axis of symmetry, is list our a, b, and c. Our a is 1. It's an understood 1 in front of the x squared. Our b is a positive 14, and our c is a positive 45. To factor, we're going to rewrite this using 2 binomials that we can multiply together to get the trinomial. Alright, so we're going to have 2 binomial factors. And the way that we do this is we use our factor cross. So this is going to be A times C, which is 1 times 45. So that's 45. And we want to know what are the factors of 45 that we can add together to get a positive 14. So let's list the factors of 45. We have 1 and 45, 3 and 15, 6 does not go, so 9 and 5. Now we need to look at the signs. A times C is positive, and our B is also positive. So that means that if we're going to multiply 2 numbers together to get a positive 45, then it has to be either a positive and a positive or a negative and a negative. So On 9 and 5, if it's a positive and a positive, well, that equals 14, positive 14, which is correct. But why is negative 9 and negative 5 not correct? Well, if we multiply negative 9 and negative 9 together, or negative 9 and negative 5 together, we get positive 45. However, if we add them together, we get negative 14. And so that's why it's not correct. Very important to look at your signs. So we can write these directly into our factors. Positive 9, positive 5. So here we go. And so then it's going to be x plus 9, x plus 5. And that would be our factors. Now how do we check this? The way that we're going to check this is to do something called an area model. So an area model. Area is equal to length times width. And so our expression that we've been dealing with in number 5 is x squared plus 14x plus 45. And we said that our factors are x plus 9 and x plus 5. Well, the way that we can check this is by placing our two binomials on each side of this area model. So x plus 9, x plus 5. And then multiply. So we're going to look for the area of this first square by multiplying x times x. X to the first power times x to the first power is x squared. X times 9 is 9x. X times 5 is 5x. And then 5 times 9 is 45. So 5 times 9, 45. Now we can bring all of our pieces of area out, so the area of each individual square, and add them together to find out what the area of the entire square is. So this entire square. And the way that we're going to do that is we're going to add each individual area together. So we have x squared plus 9x plus 5x plus 45. We have like terms. They're linear terms, not x plus 5x. So we have x squared plus 14x plus 45. Is that the same thing we started with? Yes. So we check. Excellent job. So let's look at another one. We'll look at number 7. Number 7, again, the first thing we need to do is identify our A, B, and C because there's no greatest common factor. So our A is 1. Our B is positive 2, and our C is negative 48. And so if we put this in our factor cross, we need to know what is the factors of A times C. So that's going to be 1 times 48. So that would be a negative 48. And then add together to be a positive 2. So negative 48. So multiply two numbers together to get a negative tells us that we have to have a negative and a positive. So let's look at our factors. We have 1 and 48. We have 2 and 24. We have 3 and 16. We have 4 and 12. We have 6 and 8. Alright, so we have our factors, and we know that if we want to add together to be a positive number, then the larger number has to be positive. So if we look at all of our possible larger numbers, and then the smaller number has to be negative, the positive 24 plus a negative 2 would be 22, so that's not our factor. A positive 16 plus a negative 3 would be 13, so that's not our factor. A positive 12 minus 4 would be a positive 8, not our factor. A positive 8 plus a negative 6 would equal to a positive 2. So there are our factors. So we have positive 8, negative 6. Positive 8, negative 6 equals positive 2. Positive 8, negative 6 equals negative 48. So perfect. Now we have C plus 8 times C minus 6. Let's go back and check. So we have C squared. This is number 7. Plus 2C minus 48. And we said that our factors are C plus 8, C minus 6. Put it in our area model. We have C plus 8, C minus 6. C times C is C squared. 8 times C is 8C. Negative 6 times C is negative 6C. Negative 6 times a positive 8, negative 48. We are going to combine our like terms, which in this case is on the diagonal. We have C squared plus 8C minus 6C minus 48. C squared plus 2C minus 48. Is that what we started with? C squared plus 2C minus 48. Perfect. All right, one more, and then I'll turn you loose to do this on your own. I want to do number 11 with you. Remember that we always look for a greatest common factor. So I'm looking at 2 and 16 and 40. And they're all even, so I know 2 will go into each one of them. So I'm going to divide each term by 2. And that's going to give me k squared minus 8k minus 20. And so now that I have the greatest common factor factored out, I can list my A is 1, B negative 8, and C negative 20. Go to my factor cross. A times C. So A is 1, C is negative 20, so 1 times negative 20 is negative 20. Add together to get B, which is negative 8. So what are the factors of negative 20 that would add to be a negative 8? Once again, 2 factors that multiply to get a negative means that we have to have a negative and a positive. And then if we add them together and the result is negative, that tells us that the larger factor has to be negative. So 1, start listing our factors. We have 1 and 20, 2 and 10, 4 and 5. Now we already said we wanted our larger number to be negative, so I'm going to go ahead and make all of the larger numbers negative. And then let's look. We have negative 20 plus 1. That's negative 19, not negative 8, which is what we need. Negative 10 plus 2. That gives us negative 8. So there's our factors. And I don't really need to go any further because if I look at negative 5 plus 4, that's going to be a negative 1. So we know that negative 10 and positive 2. So here we go. We can put it in our factors. K minus 10, K minus 2. And I just dropped the 2 altogether because that was just a form of simplification. Now if I had a variable there, like we did in number 2 and 4, as well as 3, if I had a variable on the outside, as you see here, then, see, we had AB out here, and we had M squared out here, then I would have had to keep what I had on the outside. Whereas, since this is just dividing, and there's no variable, just a number that we divided by, then we do not have to keep the 2 on the outside. So here we go. We're trying to balance back. I'll show you how to balance back to both. So our original equation was on number 11, 2k squared minus 16k minus 40. And we factored out a 2, so we divided each term by 2. That gave us k squared minus 8k minus 20, which we said the factors were k minus 10 times k plus 2. And we're going to test that by putting it in our area model. And we have k minus 10, k plus 2. So k times k is k. K times a negative 10 is negative 10k. K times a positive 2 is 2k. And then negative 10 times a positive 2 is negative 20. So now we're going to bring it out and combine on our diagonal. We have k squared plus 2k minus 10k is going to be minus, it will be minus 8k minus 20. And then if we wanted to get right back to where we started, we would just multiply the 2 that we divided by to start with, distribute that 2 in, and that's going to give us 2k squared minus 16k minus 40. Is that what we started with? Yes. So they check. Alright guys, I will leave the rest for you to do in Nearpod, as well as assign a matching assignment in Google Classroom. It's simply a Google slide that you'll make a copy of, and you will match each trinomial to the correct factors. Thank you so much. I hope you have a great day and stay safe and warm. Hope to see you soon.